Hello again and welcome back everybody. We are now moving into probability today, so we're starting a new unit. This is 7-1. If you have not completed the Unit 6 test as of yet, please do so as soon as you can. That and the review will be the first grades of this quarter in the gradebook. Alright, so what we're going to be talking about today is theoretical probability. So, just a quick intro here. So this spinner has 4 equal sectors, numbered 1, 2, 3, and 4. So what are the chances that if we spin, we land on the number 1? Well, since they're all equal, right, then there's going to be an equal chance for all 4 of those. So when we're doing probability, we'll get into this a little bit later, we will create a fraction, and on the bottom we're going to put the total number of outcomes there are, and we're only worried about 1/4 of those because 1 is only one of those 4. And then we will also be doing probabilities as decimals, and they're turning it into a percent, so there's a 25% chance that we land on number 1. Alright, what about chances of landing on number 4? Well, just like before, 4 is another one of those 4 chances, which is also 0.25, which is also 25%. And now, what are the chances of landing on number 6? Well, if we look at our spinner here, we only have 1, 2, 3, and 4. There is no number 6 on there. So what's the probability of landing on 6? Well, it doesn't exist, so we have no chance of landing on 6. So that's going to be 0. Alright, so now diving into some definitions here. So, probability is a measure of how likely something is to happen. And something else we can call that is a chance. What is the chance that if I flip this coin, I will get a heads? What is the chance if I spin this spinner, I will land on 3, etc. So there's many ways we can express a probability here. So can be a fraction in simplest form. We always got to reduce those fractions. Always, always, always. Can be a decimal or a percent. So just like we talked about up above on number 2, the probability of landing on number 4 is 1 out of 4, or 0.25 if I divide that out, or 25% if I turn that decimal into a percent. Alright, now an outcome of an event is the result of a single trial. So the possible outcomes are landing on 1, 2, 3, or 4 in our example above. So if I spin the spinner and I land on 2, then that would be an outcome. 2 would be an outcome of a single spin. Alright. We call an event one or more outcomes. So one event for the above spinner is landing on number 1. Another would be landing on number 4. So I think I got those mixed up. So outcome is just what are the possibilities. So the outcomes are 1, 2, 3, or 4, and the event is the one that we actually land on. So pardon me, I apologize for that. Got those mixed up. So an event is if I spin the spinner and land on 3. That would be an event that happened. And then finally, the complement is the collection of outcomes that is not, whoops, come on back here, that is not contained in the event. So in this example here, the complement of landing on number 4 is 3/4, because we have a 1/4 chance of landing on 4, so there's 3 remaining ones that we could land on. So it's basically the opposite of whatever it's asking. So the complement of landing on 4 would be landing on 1, 2, or 3, because that's the opposite of that, which would leave us fraction style with 3/4 like I mentioned, or also 75% chance of landing on everything but 4. Alright, all probabilities range from 0 to 1. We can't have a probability that is negative, so 0 is the lowest we can go, and we cannot have a probability higher than 1, because if something happens 100% of the time, well, there's no higher percentage that something can happen. So if probability equals 0, this is what we call an impossible event. So up above number 3, when we started out, it asked us about landing on number 6. We would call that impossible because number 6 doesn't exist on our spinner. Alright, now if the probability is 1, this is what we call a certain event. It's going to happen no matter what. So the example here is landing on a positive integer less than 5 on our spinner. Well, what are all the numbers on our spinner? We have 1, 2, 3, and 4. All of those are less than 5, so if I spin a spinner, that spinner, I'm going to land on one of those every single time. So we call that certain. Alright, so now we have our big old number line here with things that we use to describe probabilities here. So, probability 0, we said never happening or impossible. If the probability is 1/2, we call that an equal chance or a 50-50 chance. And then p equals 1, probability of 100% or 1 is certain to happen. So if something is in between 1/2 and 1, we call that more likely. If something is in between 1/2 and 0, we call that less likely. And then we have impossible, equal, or certain. So just ways to describe different probabilities here. So now we're getting into theoretical probability. So this is, excuse me one second. Theoretical probability is the probability based on what we think will happen or what we expect. So this is where all the math comes in, as in the theoretical bit. So what we expect to happen based on what we know from the information that we've been given. So if all the outcomes are equally likely, then we can use this formula here. So theoretical probability is equal to the number of favorable outcomes, or we call that what we want to happen, divided by the total number of outcomes. So from our spinner up above, if the probability of landing on 1 was 1 out of 4, because there are 4 total things we could happen, and we are only interested in one of those. Interested. Alright, so we've got an example here. The letters A, B, C, D, and E are written on 5 individual tiles and placed in a bag. Find the probability of each event below. So what is the probability of drawing a vowel? Well, we've got 5 letters in there, right? And how many of them are vowels? The only vowels that I see are A and E, right? So 2 of those outcomes are favorable for us because 2 letters are vowels. So we have a 2/5 chance of drawing a vowel, which as a decimal would be 0.4, which as a percent would be a 40%. Now, we've got what's the probability of drawing a consonant? Well, if 2 are vowels, that means the rest are consonants, right? So there's still 5 letters in there. And how many consonants are there? Well, there are 3. So as a decimal, that will be 0.6. And as a percent, will be 60%. So 3/5 is the chance I have to draw a consonant out of that bag. And now what is the probability that we pick an A out of the bag? Well, there's still 5 tiles. How many of those tiles are lettered A? Well, that's only one of them, right? 1 out of the 5 is an A. So, as a decimal, 0.2. As a percent, 20%. So we're going to be thinking about this a lot, equating fractions, decimals, and percents here. All right, now we've got this example number 2. Juanita only has 3 pairs of black jeans, 2 pairs of dark blue jeans, and 3 pairs of white jeans in her closet. She reached into her closet without looking and picked a random pair of jeans, expressed as a fraction. So we've got, what's the probability of drawing a dark color? Well, how many jeans does she have in total? Well, looks like she's got 8 pairs of jeans altogether. So I'm just going to use this as a fraction bar. 8 total pairs of jeans, and how many of them are a dark color? Well, black is a dark color, and dark blue is a dark color. So 3 pairs of blacks, 2 pairs of dark blues is going to be, she has a 5 out of 8 chance of getting a dark color, which would be 0.625 or 62.5%. What's the probability of drawing white? Well, she has 8 total pairs of jeans, and 3 of them are white. So 3/8 or 0.375 or 37.5%. All right, now what's the probability she draws a pair of red jeans? Well, does she have any red jeans? No, they're all black, dark blue, or white. So the probability of drawing red is going to be 0 because red jeans don't exist in her closet. That is impossible. And what is the probability she draws a pair of jeans at all? Well, there's 8 pairs of jeans, and she could pick any one of those 8. All 8 of them are jeans. So it's going to be equal to 1 or 100%. It is certain that if she grabs a pair of her pants, they will be jeans. All right, so any probability thing we're doing for theoretical, we just make a fraction out of it. So we put what we want to happen on the top and the total things that can happen on the bottom. All right, so with these, go ahead and give them a try. Pause the video, and I will go over, and then you can give it a try on your own, and then push play again and see how you did. So if we roll a 6-sided number cube, we want to express these as a fraction, so don't worry about decimals or percents. So what's the probability that I roll a 1? Well, how many total sides do we have? We've got 6 numbers on there, and 1 is only one of those numbers. So 1/6 is the chance we have of rolling a 1. Now a multiple of 3, let's count out what our multiples of 3 are on a dice. We've got 3 and 6, and those are the only 2. So we still have 6 total possibilities, but now we have 2 of them being what we want to happen, which always reduce your fraction. That's going to be a probability of 1/3 that I roll a multiple of 3. All right, so now we want the probability of not rolling a 2. So there's still 6, nothing's changing about our dice. How many of those numbers are not 2? We have 1, 3, 4, 5, and 6, which gives us 5 total numbers that are not a 2. So 5/6 would be the chance we have at rolling not a 2. Probability of 9. Well, does 9 exist on a die, a regular 1 through 6 die? It does not. So that is an impossible situation here. So we're going to call that 0. And then probability of rolling an even number. Well, there's still 6 altogether. And our evens, we have 2, 4, and 6, which gives us 3 possibilities. Remember, always reduce your fractions. That's going to be 1/2. All right. So finally, a glass jar contains 6 red, 5 green, 8 blue, and 3 yellow marbles, and we pick a single random marble out of a bag. So what's the probability of drawing red? Well, how many marbles do we have in total? I count 11, 19, 22 marbles. And how many of them are red? Well, that will be 6, which we can call 3/11ths. Now, what's the probability of drawing a green one out of this bag? Well, there's still 22 marbles, and we pick a green. So there are 5 green ones in there. Probability of blue, still 22 marbles, that's not changing, and 8 of them are blue. Always reduce your fraction, so we've got 4 out of 11 chance of getting a blue marble. Now red or yellow. So how many of these marbles are red or yellow? So we have 6 reds and 3 yellows, so that's going to be a total of 9 marbles that we would want to pick out of that. Finally here, what's the probability we draw a purple marble? Well, are there any purple marbles in the bag? It doesn't tell us there are, so there is 0. And the probability that we pick a marble when we pick a random marble, well, that's going to be certain that we get one. Doesn't matter what color it is, we're just seeing how we draw a marble. All right, and then back to part A, the probability we draw an integer. Well, there's 6 integers on our dice and 6 possibilities that we would like being integers, so that is a 100% chance, certain. All right, so our independent practice here starts below the try these, where it's obviously labeled independent practice. So go ahead and give these a try when you are finished. As always, take your photo, submit to Canvas, and I will get that graded. If you run into any issues, feel free, as always, to send me an email, send me a message on Canvas, and I will reply to you as quickly as I can. All right, thank you and have a great day, and we will talk to you again here soon. Bye-bye.